Good afternoon and welcome to the 29th annual exhibit of hydrogen and fuel cell technology at the Hanover Fair. It's 2023. We've been here since the mid-90s talking about this technology. Largely we're dedicated to renewable energy. So we love renewable sources, wind, solar, they're wonderful. Largely the problem is it has to be stored. Not everything is consumed in the form of electrical energy. Someday we're going to be shipping hydrogen, which is produced with electricity all over the world. That, ladies and gentlemen, is an electrochemical reaction. Without an electrochemical reaction, you cannot produce hydrogen from water. Without an electrochemical reaction, you can't operate a fuel cell, which reverses the process and combines the molecule with ambient air to produce electrical energy. Everything seems to be an electrochemical reaction. So we need a professional who can tell me about the electrocatalysts, the catalysts that actually create the reaction or facilitate the reaction inside these devices. I'll be talking to Thomas Stephenson, who is CEO and chairman of Pajarito Powder, about improved system economics with advanced electrocatalysts. Please welcome with me Tom Stephenson. Good morning, Tom.
Thank you, Brian.
Or good afternoon.
It's afternoon here.
It's
Still
afternoon here.
Morning in America.
Morning in America. Yeah. Well, good morning to all those people from America who are on the live stream, of course.
That's right.
Pajarito Powder, could you give us sort of an overview of what the company is, what it does, and where you're located?
Yeah, sure. So we're located in the southwestern United States in Albuquerque, New Mexico. And what we do is we've developed and we manufacture catalysts for both electrolyzers and for fuel cells. Fundamentally, for those of you who can see, it looks like this. It's a simple black powder, but it's very, very important because it's at the core of fuel cells and electrolyzers. And we do the catalyst formulations as well as support materials for PEM fuel cells and then also for PEM electrolysis and also for AEM electrolysis. So we've got a wide range of products. Some of those are still very much in the developmental stage, but we've got a variety of products that we've had out on the market for some time for both the fuel cells and for electrolysis.
Of course, everyone knows largely that electrolysis is all about chopping that water into hydrogen and oxygen and reusing the hydrogen. We have occasionally fussy engineers here, and they look at this process and they say, oh, you know, electrolyzers are not really as efficient as we'd like them to be. Is this true? Do we have an efficiency issue with electrolyzers?
Well, I think that we don't really have an efficiency issue with electrolyzers, but what we have to do is we have to look at the use case and in almost every circumstance. And one of the interesting things is that when you start to look at the transmission of energy, as well as the long-term storage of energy, that's much better to do in the form of molecules. And I suspect in this group there's not going to be any, that's not going to come as any great shock, but some of the studies suggest that for long-distance transmission, for example, that you can have 3 to 8 times better efficiency in the transmission of energy in the form of molecules over long distances than you can if you do it in the form of electrons. And so combining that with the opportunities that exist for the renewables that, of course, are first taking the energy and converting it into electricity allows you to really be able to cover the entire landscape. Long-term storage, long-term transportation, short-term, short-range storage and transportation in the form of batteries, and then also the use of the electrolyzer and the fuel cell for the conversion back and forth between the electrons and the hydrogen.
So it's not all about efficiency. And by the way, if we want to harvest all this renewable energy, there's no way around storage. If you want to ship it, if you want to transfer it from one place to another, these are economic goals, of course, and they always raise the economic issues of the cost of electrolysis. And I believe some of the costs are literally the electrocatalysts themselves. How do you address the cost issue in terms of the materials that are built into the electrolyzers?
Right, so when you start to talk about building an electrolyzer, the CapEx component associated with the overall cost of using it, then the electrocatalyst is a huge portion of the overall cost. And that's because what you can be looking at is for a PEM electrolyzer, you need to use iridium. You also need to use some platinum. And the estimates using sort of today's technologies are that you're going to be looking at anywhere from 150,000 to 200,000 euro per megawatt of electrolyzer capacity. So there's a substantial economic piece that suggests that to the degree to which we can start to reduce the amount of precious metals, not necessarily eliminate, but reduce the amount of iridium and the amount of platinum that are in particularly a PEM electrolyzer, then we have the ability to very dramatically change the economic opportunity, because the overall system costs in terms of the CapEx start to come down substantially.
Any idea how much that bottle costs?
Well, I'll be honest with you, we bring this bottle to trade shows, so we don't have any iridium in it. We don't actually, I'm not allowed to leave the building with any of the iridium, but it would be, I mean, this would be something that would include probably 20 to 30 grams of iridium in it, and that's going to run, in US dollars, that's going to be anywhere from 3,000 to 4,500 just carrying around in the bottle. But and it is just carbon in the demonstration bottle, so you should not run off with it.
Okay, I can't buy my new laptop with that bottle.
Not with this one, no. But we do have others that you could.
I get the idea. The big goals we have here are already visible at the fair. That is, in the good old days, and you've been here before, so in the good old days when I started 20 years ago, there were a few hydrogen reforming projects. They basically use the dirty, nasty natural gas that is no longer being delivered anyway from Russia and divide that up into the carbon and the hydrogen, and you have what they call gray hydrogen. The way we're going right now at the fair is most of the square meters here are occupied actually by the electrolysis industry. That is, this is already visible. This is exponential growth and more.
Absolutely.
To what extent are you affected by by this exponential growth?
Well, so we're affected in a couple ways. So first of all, in a very positive way, we saw a 700% increase in the growth of our electrolyzer catalyst sales in 2022 over 2021. And we're already on pace to see even greater growth for 2023. So the demand is increasing at exactly what you're saying at that exponential level. But what's interesting about it is if you sort of step back for a second, all right, and talk a little bit about what the overall impacts are and why we do what we do, which is to focus on the development of novel catalysts, which are going to allow us to reduce the amount of iridium that's necessary per megawatt. And we're doing it. Other folks in the catalyst industry are doing it as well, because this is recognized as a very substantial problem. All right, and it is a substantial problem not just because of the cost that I cited before, but because we simply don't have enough iridium in the world to be able to do what we want to do. So if you do a sort of back of the envelope calculation, and you say just to meet the goals, the more aggressive goals, but the goals that the European Union has established through REPowerEU, much less including the goals from America, from Asia in terms of Japan, Korea, China. You just look at Europe for a second. You'd say between now and 2030, over that cumulative period of time, you're looking at needing anywhere from 100 to 150 tons of iridium. All right, well, is that a lot? Well, when you stop and think about the fact that the worldwide annual production of iridium is just over 7 tons, which means in that same period of time we would be producing anywhere from 50 to 60, it's a big deal. And in order to get a little bit better visualization of that, we brought along a graph. And if we could go ahead and put that up. Our friends at Johnson Matthey wrote a white paper not too long ago where they sort of described the overall amount of iridium that would go in there.
We're looking for the slide for the iridium.
What you can see is that, and go ahead and cycle through it because it's got some interesting steps. But what the folks at Johnson Matthey wrote up, and which my colleague has illustrated with this graph, is that you could fit all of that iridium into 7 carry-on suitcases. Don't try to lift them. Don't try to put them in the overhead bin, because this material is incredibly dense. But the point is that what we're talking about driving our entire industry is material that could fit in the size of 7 suitcases. We're going to need to come up with better solutions if we're going to ultimately be successful. What does that mean? We need new types of catalyst. Those catalysts are going to help us reduce the amount of iridium that's required. We're going to need recycling to go with that. And we're going to need to look at alternative chemistries for electrolysis, like AEM, that can operate without the dependence on iridium or platinum.
Could you define AEM for those people who are not up to scratch?
Sure, that's the counter to PM, but it's the alkaline electrode membrane electrolyzers that operate in an alkaline environment. Because of the natures of those chemistries, they don't require the precious metals in the same way that the PEM electrolysis does.
Okay. The issue is so surprising for me simply because I do the elevator pitches for the electrolysis industry. So you have these CEOs from, comparatively speaking, monster companies here. There's a lot of small and medium-sized players. These guys are often publicly traded corporations.
Right.
They're all standing on the stage, 7 of them, and they're talking about reaching a goal of 6,300 gigawatts at a certain time in the future, 2050 at the latest, of course. I asked them for the first time this year, can you actually envision how you're going to create supply chains that provide all of the materials? We know that there's an issue with batteries. Simply transitioning all vehicles that are operating today into battery-powered vehicles means we'll be mining for the next 370 years. So there are bottlenecks here, and it's important to be aware of them because we are talking about a necessary change to green energy, and at the same time, we're not really being open about where the bottlenecks exist. So I asked these guys, where are the bottlenecks? And they looked at each other and thought, are we going to talk about this? Are we going to talk about this publicly? This is the first time I've had a public conversation about this issue, which is so vital. When we talk about bottlenecks, how close are we to them now? Is it already an issue for other industries that compete often for precious metals? And are these resolvable? You've mentioned that there are alternatives. Are the alternatives always viable? Are there cases where we need iridium and other precious metals?
Yeah, so first of all, the electrolyzers are not the only use of iridium. They're used in the telecommunications industry. I like my phone. I want to keep using it. So there's clearly going to be a continued need for the use of iridium in that industry and in other industries as well. Not to mention the fact that you have all the problems that exist with commodity pricing, that if you start to see an increased demand come in, that results in higher prices, which just further amplifies the effect. The problem is not the problem today. There's enough iridium out there. It's possible for the folks who supply the iridium to be able to work with the catalyst companies like ourselves to be able to provide it. But it is something that we have to keep an eye on for the future. And one of the things that this sort of ties back into is the other piece that I think is sort of critically important when we think about the scale-up process, that we have to think not only about what's going on with the scale-up for the electrolyzer manufacturers themselves, but the entire supply chain. And building out that supply chain is going to be very critical, which means we need membrane, we need ionomer, we need the plates, we need catalyst. For our purposes, we're very excited that we are in the process of building out a new manufacturing facility in Albuquerque, New Mexico, in the U.S., where we're based, that's going to allow us to be able to produce several metric tons worth of material, which will allow us to continue to scale and grow with the needs of the industry. And obviously that presumes the availability of the inputs that we need, the precious metals like iridium and platinum, but with that it'll allow us to continue to grow with the needs that our customers have. And we're going to need to see that same support by industry into the supply chain as well as the end users to be able to make sure that we can have a seamless set of supplies that come from the raw materials all the way through to the ultimately to the electrolyzer products that are going to be making the conversion of the electricity into hydrogen. That has to be coupled with additional research. You asked about the viability of AEM. You know, there are companies that are doing AEM products today. They need to be scaled up to larger sizes. There continue to be some additional technological challenges, less so on the catalyst, but some in other areas, in order to be able to continue to see that portion of the industry grow. And I think most of the experts that I've talked to and people that I've read suggest that that the grid level types of AEM solutions are likely going to be several years out. Again, there are people that are doing it right now today, and they're going to be in a strong first mover advantage if they can continue to scale up their offerings to meet the grid level requirements.
Is there any scenario for increased efficiencies to the extent that it actually removes the issue of iridium bottlenecks?
I don't think so. So my short answer to that is no, because there's just a limit to how much efficiency that we're going to be able to get out of a certain system, and that for that to be the mechanism to reducing the precious metals. I think we're going to have other technology solutions that reduce the precious metals, better catalysts that reduce them, and also recognize that we're going to have to do a lot of work around recycling so that we can continue to get those materials back when we reach end of life for electrolyzers that come out of the field when they're done with their service.
How do you see the forces that are driving this expansion of electrolysis, which obviously affects your business model? To give you an example, in Germany right now, we do relatively often turn off already financed wind turbines. That's a CapEx, a capital expenditure, and if you're not operating a wind turbine when it should be operating, could be operating, you're losing money. And we're turning it off because we cannot store the energy. The grid can't absorb it. There's no scenario where batteries can store these quantities of energy. So we do need electrolysis. But I'm not sure whether that is a larger driver than the need to decarbonize, for example, the industries. When you think of the applications of this technology, there's also political, of course, incentives and decisions, policies in the European Union. Do you have any philosophy on the drivers of this change and how you explain 700% growth? That is phenomenal.
Yeah, so I think there's obviously a number of different forces that are at work, and there are policy experts that focus in on this on a day-to-day basis, where we focus in on making and selling our catalysts, obviously. But the short answer is that I think that as we look to the roles and the goals of decarbonization, the opportunities that exist for hydrogen, which is why the hydrogen market is growing so quickly, move beyond just transportation. You look at the estimates that come from the Hydrogen Council about how much hydrogen is going to be required when we go out to the out years like 2050, and transportation represents the largest piece of it, but it only represents about a quarter of the total amount of hydrogen that's going to be necessary. Other components are going to go to storage. They're going to go to the decarbonization of steel production, of concrete production, of ammonia production. These industries that right now desperately need to be involved in cleaning up how they're doing it. And they're in the process of doing it right now, but they're going to be huge drivers for the growth of hydrogen. Your example about with the stranded renewable energy has always been a really fascinating one for me, because you have this opportunity. The standard argument that I hear against electrolysis as a hydrogen production technique, right, is that two pieces. One is the CapEx is too high. Well, a lot of that's driven by the catalyst. We're working on that. But that also the OpEx is too high. And the OpEx estimates all are based on the idea that you're paying a sort of standard level of energy cost. But if you're in a situation where your choice is to turn off your windmills because you don't have the energy, or sell them at a cheap price, or give it away to another country, which I believe has happened to Germany as well in the past, then the idea of being able to take that and convert it into hydrogen, which you can store it, means that the operational expenses get very, very low. And so these represent great opportunities, particularly if you have a very substantial difference in winter and summer, as you do in Northern Europe, between the amount of sunshine that you get in the summertime and the amount that you don't get in the wintertime. And as a result, I think that opportunity for storing energy is just going to be a huge application for hydrogen going forward. We're big fans of that, particularly in places like Northern Europe.
Tom, of course, is being a gentleman, so he didn't mention the issue of energy security. Every time I talk to people from the Department of Energy, they say, it's a no-brainer. What did we do in Germany? You can weaponize hydrocarbons. We need to diversify our energy supply in Germany desperately. We see this in the prices and the volatility. The industries depend on this, and we're the #1 per capita manufacturing country in the world. This is a ridiculous position to be in. And what we really need is so much electrolysis that hydrogen is going to be traded like a standard commodity, like hydrocarbons in the past century. There are going to be ships with hydrogen. Who knows how it's going to be translated in the form of ammonia? We don't know yet. But when we talk about all these issues, what is your midterm outlook right now? We still have a minute to go, and I need a sort of big bang ending here, Tom.
Well, you hit it with this question of energy security. And when I get asked by people who aren't in our industry about, do I think that this is a cycle, or do I think that this is something that's really here to stay? Are we going to be able to hold to some of the issues around decarbonization? The issue that changes the game is energy security. All right, what has happened today is that while it's always been there, it's moved up to a much higher level where now saving the planet, which ought to be good enough on its own, is only part of the overall solution associated with why we need to make this transition away from fossil fuels. And energy security has moved up in so many countries, Germany, other elements of Europe, to being one of the top considerations, if not #1. And as a result, that's why I think it's going to stick, because that's an issue that holds across demographics, across age groups, and across industries, and as well as across countries. And as a result, we're going to see that hold and be something that we have to keep moving for continually. It's not going to be a cycle. It's going to be something that's very much here to stay. And that's why I'm an optimist about what we're doing. But I'm also in the industry, so I'm supposed to be an optimist about it.
Well, we are too, and I hope to see you back here next year, because we have to continue as we're here to stay.
Absolutely.
Right?